What's up, people, and welcome to my tutorial in Pragmatic Data Science. So in the previous video we looked at how you would perform vector multiplication and also how it can be done with NumPy, right? And the next question that arises is you have this values vector right here, but this is only mapping to one row of our data set. Basically, if you remember the CSV file that we were using, you can think of the values vector as one row here. But as you know, we have multiple rows in our data set, and of course we can, in memory iterate over this and just multiply them one by one, right? But there is also another way that you can do this. So you would smack all this row into a matrix instead of a vector. And that is what we're going to look at now and how that can be done. And that is vector and matrix and vector multiplication. So now we still have this V2 matrix here, and if you've been following along with the videos, you can think of the V2 matrix as the weights of the thetas basically that we have for triggering on or off and putting weights on the different columns of the data set. So how much they're going to affect the output. And these won't sum up to 1 or anything, but it doesn't really matter at this point. So what we have here instead is the M1 matrix, where we have taken one row from the data set and put it in here, and then we have some other data row here, and then you can have arbitrarily large data. So you can think of this as the CSV file data rows, like one row here would correspond to one row here, and next one, next one, next one. But now we have only grabbed 2 rows from the data set in here, and that is why we have 2 rows here, and we have 4 columns because we have 4 features from our data set, and that is also why this length here is also 4. And I've notated the shape like this. So first off, the first matrix here, M1, that is going to have the shape 2, 4 because it had 2 rows and 4 columns, right? And V2, it has 4 rows and 1 column. So that means that first, the thing we check first is, are these 2 numbers the same? Yes, they are. Okay, that means that you can actually multiply them together. And then you check this outermost values here, which is going to be the new shape of our output matrix. And that is going to be two rows and 1 column. And you can see that here if you looked into here. So now when we multiply them, we're going to get a vector that has 2 rows and 1 columns. All right, so how is this actually performed? So how this is done is basically, you can think of it like where these intersect if you overlay them. So you're going to take 2 times 0.2, and then you're going to take 3 times 0.6, and then you're going to take 7 times 0.7, and then 1 times 0.1, right? And then you're going to sum them up, and that is going to be this value right here. And now for the second value, you're going to take the second row here, 4 times 0.2, and then 2, 0.6, and then 1 times, and so on. And then you're going to sum them up, and that is going to be the next row here. So if you overlay them here, you can think of it like where these 2 matrices intersect is going to be the position of the new value, or intuitively that's how I think of it. And for sanity check, you can see that also it's going to have this shape. So if that confuses you, doing this with the 2 matrices usually helps me with figuring out how it's done. And if you want to do this in NumPy, you would do the same thing. You would import NumPy, and then you would create this V2 matrix, vector, with these values in here. And then when you creating the M1 matrix here, you would do this. So you would have the first row here, which is 2, 3, 7, 1, which is this one right here, and then you would take the next row here and put it in there, which is going to be this one. And then you just do the same thing. You do np.matmul and then m1 times v2, and then you would get also this output. All right, so I hope I didn't confuse you guys too much, and don't forget to subscribe and leave any comments if anything is unclear, and I hope I will see you in the next video. So see you, bye bye.